So now we're going to look at the other part of page 72. We're going to look at problems 4, 6, 10, 11, 12, and 14. So let's get started. Okay, and let me just go back here. Yeah. So we'll start with problem number 4. If minus 1 is a solution of x squared plus kx plus 5 equals 0, find the other one. So here's the original equation, that we know one of the factors has to be x plus 1 because x comes out to be minus 1. If we set x plus 1 equal to 0, we get x equals minus 1. So one of the factors has to be x plus 1 for this equation. And so the only other alternative that's going to give us plus 5 here is if we use x plus 5, because the last term, plus 1 times plus 5, has to give us plus 5. If this is plus 1, this has to be plus 5. So the other solution would be, if we set this equal to 0, there are two solutions for this. X plus 1 equals 0, and x plus 5 equals 0. If x plus 1 equals 0, then minus 1 is one of the solutions. If x plus 5 is 0, the other one is minus 5. So if you want the coefficient of the middle term, it obviously is the coefficient of the middle term here, and it is 6 right here. So the answer to this would be x is minus 5. Solve for x in terms of k. So here we take the original equation and we factor it. So we have to find the factors of k squared x squared, and that's going to be kx times kx gives us k squared x squared. And now we're looking for minus 10 as the last term. If we choose minus 5 and plus 2, then we get the correct middle term, because the inner term is minus 5kx right here. Minus 5kx is the inner term, and the outer is plus 2kx. So the inner and the outer sum to minus 3kx. So let's go over that. Kx times kx gives me k squared x squared. Minus 5 times plus 2 gives us minus 10. Minus 5kx plus 2kx gives us minus 3kx. We're using FOIL, and the combination of the inner and outer term have to give us minus 3kx. We couldn't have used 10 and 1 as the factors here, because there's no way we would come out with minus 3kx. What if you put plus 5 and minus 2 here? You'd come out with plus 3x. So the signs, you have to watch out for the signs. So when we factor this, we get that. Now, if the product of two factors is 0, either this equals 0 or this equals 0. If we solve this for kx equals 5, we transpose this from the left to the right, we get plus 5. If we transpose the plus 2 from the left to the right, we get minus 2. And if we divide this by k to get x, we have to divide this by k to get also. So x is 5 over k. I divide this side by k, I get x. Divide this side by k, I get that. So the solution is 5 over k, or minus 2 over k. Now let's check these answers. Let's check 5 over k, and we plug it into the left side. We get k squared is this one. X is 5 over k, but it's x squared, so we do 5 over k squared. Minus 3k is this minus 3k, and instead of x, we write 5 over k. And this is minus 10 is this minus 10. Now, this becomes 25 over k squared when we square it, and the k squared here and the k squared there cancel, and we're left with 5 squared, which is 25. The k here and the k here cancels. Minus 3 times 5 gives us minus 15. This is minus 10, so we have 25 minus 25, which is 0. And the right side of the equation is 0. Let's check with minus 2 over k. K squared x squared. Instead of x, we write minus 2 over k all squared. Minus 3k is right here. X is minus 2 over k minus 10. Now this becomes 4 over k squared. So the k squared cancels, and I have 4 here. This, the k here on the numerator, on the denominator and the numerator cancel. Minus 3 times minus 2 is plus 6. And we have minus 10. So 4 and 6 is 10. 10 minus 10 equals 0. And the right side equals 0. Find the sum of the squares of 3 consecutive integers. The sum of the squares of 3 consecutive integers is 110. Find them. So we say let x equal the first integer. The next one that comes after that, if it's consecutive, means that it's one more. And the third one is plus 2. So it would be, for example, if this was 5, this would be 5 plus 1, and this would be 5 plus 2 if those were consecutive integers. But we don't know what they are, so we're going to identify them as x, x plus 1, and x plus 2. And it says the sum of the squares. So here's the first one squared, here's the second one squared, and here's the third one squared, and the sum is 110. Now, if I expand, this is x squared. X plus 1 times x plus 1 is x squared plus 2x plus 1. This, if I multiply x plus 2 times x plus 2, gives me x squared plus 4x plus 4. And this 110 is this 110 here. So if I sum the x squared here, the x squared here, and the x squared here, I get 3x squared. If I sum the 2x plus the 4x, I get plus 6x. And if I sum the 1 and the plus 4, I get plus 5. Now I transpose the 110 from the right to the left. It becomes minus 110 plus 5 gives me minus 105. First thing I'm going to do is look for the greatest common factor, which is 3. 3 goes into 3. 6, and 105. 3 times x squared gives me 3x squared. Plus 3 times plus 2x gives me plus 6. And 3 times minus 35 gives me 105 equals 0. So I have x squared plus 2x minus 35 equals 0. If I just drop this, I take this, and I factor this, and the factors are plus 7 and x plus 7 and x minus 5. The first times the first gives me x squared. The inner one is plus 7x. The outer one is minus 5x. And I get plus 2x, and plus 7 times minus 5 equals 0. So the solutions, if x plus 7 times x minus 5 equals 0, the solutions are that x could equal minus 7 or that x could equal 5. Now if I take minus 7 as the answer and I add 1 to it, I get minus 6. And if I add 2 to minus 7, I get minus 5. So I go back here, and this one is minus 7. This is minus 7 plus 1, and this is minus 7 plus 2. And that's how I get minus 7, minus 6, minus 5. Now, if I choose 5 as the answer, x is 5, x plus 1 is 6, and x plus 2 is 7. You sum the square of these, 5 squared plus 6 squared plus 7 squared, get 25 plus 36 plus 49, which is 110. You do the same thing with the minus 7, the minus 6, and the minus 5. You square them and then you sum them. You get 49 plus 36 plus 25, which also gives you 110. The product of two consecutive integers is 11 more than their sum. So let x equal the first integer, and the second one, consecutive means it's one more. So x plus 1 is the second one. The product of those is 11 more. That means if I subtract 11, it is equal to their sum. Here's the sum. X is the first integer plus x plus 1 is 11. Let's read that again. The product of two consecutive integers, that's this, is 11 more than their sum. So I can subtract 11 here and make it equal to the sum. Or if you want, you could say x times x plus 1 equals x plus 1 plus 11. So you have the choice. Either you can put the minus 11 here, or you can put the plus 11 here. It doesn't make any difference. It still work out in the end for the same value for x. So x times x gives me x squared. X times plus 1 gives me plus x. This is minus 11. X plus 1 gives me 2x plus 1. Now what I'm going to do is bring this over to the left side. X minus 2x gives me minus x. Bring the plus 1 from the right to the left. Minus 11 minus 1 gives me minus 12. And this factors to x minus 4 and x plus 3 equals 0. So this should read, this should read what two numbers? So what two numbers when multiplied give minus 12 and sum to give minus 1, and the answer is minus 4 and plus 3. So minus 4 and plus 3 give us the minus 12 and sum to give us minus 1. So we have minus 4 plus 3, minus 4 plus 3. You can see that the inner term is minus 4x, the outer is plus 3x, and that gives us minus x. The minus 4 and the plus 3 gives us minus 4 and plus 3 gives us the minus x, and I'm sorry, minus 4 times plus 3 here gives us the minus 12. So these are the factors. We want to factor this. When we factor, it's this. The first times the first gives us the x squared. The minus 4 times the plus 3 gives us minus 12. The inner is minus 4x. The outer is plus 3x, and that gives us minus x. So when we factor this, we make x minus 4 equal to 0. X is 4. X plus 3 equals 0. X is minus 3. So the two numbers, if the first one is 4, then the next one is 5, the next consecutive integer. If the first one is minus 3, which is right here, and we add 1 to it, we get minus 2. So let's check this out. The product of 4 and 5 is 20. The sum is 9. 20 is 11 more than 9. So the product of minus 3 and minus 2 is plus 6. The sum is minus 5. The difference between plus 6 and minus 5 is 11. Okay, here we have let x equal number. X is the square of the number. We're looking for the sum of a number and its square is 132. So we let x equal the number. X squared equals the square of the number. We square x. The sum of the number and its square is 132. We have x plus x minus 132 equals 0. What are the factors of minus 132 to sum to plus 1? The answer is 12 and minus 11. And you can see here x times x gives me x squared plus 12x minus 11x gives me plus x right here, and plus 12 times minus 11 gives me minus 132. So I'm using the FOIL method on this line to make sure it equals this line. The first times the first gives me x squared plus 11 times plus 12 times minus 11 gives me minus 132, and the inner plus 12x minus 11x gives me plus x equals 0. So if x plus 12 equals 0, x is minus 12. If x minus 11 equals 0, x equals 11. So now we take the sum of minus 12 and minus 12 squared, and that would be minus 12 and 144 gives me 132. The sum of 11 and 11 squared, or 121, we sum 11 and 121, we also get 132. So the solution is 11 or minus 12 right here. So either one of those solutions. So the sum of a number and its square is 132. And we saw there are two solutions here. 11 squared is 121, and plus 11 is 132. In this case, if we use minus 12, we get 144. 144 and minus 12 also gives us 132. So those both check out. So let's take a look at number 14. The sum of an integer and its square is 9 times the next consecutive integer. Find the integers. So here we have the sum of an integer and its squares equals 9 times the next consecutive integer. The next consecutive integer to x is x plus 1. So we have x squared is this one, this x is this. We transpose this from the right to the left, we get minus 9x. We transpose 9 from the right, we get minus 9. And now we have x squared plus x minus 9x is minus 8x. And here we have minus 9 equals 0. And we have x plus 1 times x minus 9 as the factors. The first times the first gives us x squared, plus 1 times minus 9 gives us minus 9. The inner is plus x. The outer is minus 9x. Plus x minus 9x gives us minus 8x. So the solutions of x plus 1 equals 0, x equals minus 1, and x equals 9 equals 0, then x equals 9. So if we check with x equals 9 here, and we put this into the left side, x plus x squared, we get 9 plus 9 squared, which is 81. We get 90. The right side is 9 times x plus 1. And so this is 9 times 10, which is 90. We check with the minus 1. The left side is x plus x squared minus 1 plus minus 1 squared. This becomes plus 1. Minus 1 plus 1 equals 0. The right side is 9 times x plus 1. So instead of x, we write minus 1. Minus 1 plus 1 is 0. 9 times 0 is 0. So the solutions are 9 or minus 1. And that completes the problems on page 72.